Hey guys, let's talk about 5.3, solving linear systems in 3 variables. Okay, so we've done systems of equations with 2 equations. This is 3 equations. This is kind of a lot. Basically, you break it down. So to solve using substitution, we're gonna solve for one of our variables, right? So I've taken this first equation here. Let's do this. So this first equation I've taken and solved for x. So I'm going to take this solution for x and I'm going to substitute it in to both of my other equations. Substitute it in there and substitute it in there. So the top equation, or middle equation, I should say, top one I used to solve for x. So the middle equation here, I solve for x in the first one, right? Got x by itself, and that gave me x equals negative 2y minus z plus 8. Plug that whole thing in for x here, and then solve. Distribute my 2, and then combine my like terms, and that gives me this. And then I do the same thing with this bottom equation. Substitute this in for x. So that gives me negative 2y minus z plus 8 plus y plus 3z. I combine my like terms. That gives me this equation. So now I have 2 equations I can work with. Because if I'm doing a system of equations with 2 that have 2 variables, I can handle that. So here are the 2 equations that I got from substituting in this top one to the other 2. By the way, it doesn't have to be the top one. You can pick any of these equations to solve for any of the variables, and then plug what you get into that variable for the other 2 equations. You'll get the same answer. I just picked the top one because I saw the x coefficient was 1, and I knew that was going to be quick and easy. So that's why I picked that one. So now that I've got 2 equations I can work with, basically your goal is to break down the 3 system of equations into a 2 system of equations so you can work with it. So I picked this bottom one to solve for y. So this, I subtracted 2z on both sides, so that gave me negative y equals negative 1 minus z, divide by negative 1, and I get this equation here. So after I've got this equals y, right? So I'm going to plug that back in to my other equation. So negative 3 times all of this stuff, because that's what y equals. So that's what happened here. Negative 3 times 1 plus 2z minus 3z equals 12. I distribute my negative 3. I combine my like terms. And I finally have a solution. Yay, I have one of my answers, right? I've got z equals 1. Awesome. So I'm going to take that z equals 1 and plug it back into one of these equations so I can solve and get an answer for y. So that's what happened here. I took this z equals 1 and plugged it into this bottom equation. So if z equals 1, then negative y plus 2 times 1, that's where I put that z equals 1. And then we're going to multiply, we're going to combine our like terms, divide by negative 1, and now I've got an answer for y. So if z equals 1, then y equals 3. And now that I have 2 of these guys, I can go back up to my original equation, plug it into any one of these 3, and it'll give me my other one, right? So I just picked the top one. So if z equals 1 and y equals 3, then from this top equation, x equals 2 times 3 plus 1 equals 8. There we go. So then I'm just going to do a little algebra. multiply my 2 and my 3, combine my like terms, subtract 7, and that gives me my x. I did it. I did it. And then you write it like this. This is how you write it. X, comma, y, comma, z. This is for a specific three-dimensional point. Remember, we've got our x and our y. Our z gives us the depth of that point. So this is like a three-dimensional point on a plane. And that's what the 3 solution is. So that was using substitution. This is kind of long and drawn out, but it's all we're doing, right? All we're doing is some basic algebra. Look, we find one of our variables, we plug it in, we multiply, we combine like terms, we solve. That's all we're doing. We're not breaking any new ground here. It's about doing it in the correct order and doing it in the right steps. Follow this guide for substitution, and I think you'll be all right. Let's talk about solving using elimination. This, I think, is kind of an easier way to do it. So I've put equation 1, 2, and 3 here to label these guys. So again, we have a system of 3 equations. We've got an x, a y, and a z that we need to solve for. So when we did system of equations with 2, solving by elimination was always a method. We could add or subtract our equations to eliminate a variable. So we need variables to have the same coefficients to eliminate. Add or subtract equations to eliminate a variable. Okay. So 1, this is my first equation, right? Up here I've got x plus 2y plus 3z equals 9. That's what I've got here. And 2, my second equation, x plus 3y plus 2z equals 5. These are the same, right? So if I added them, that wouldn't get me anywhere. It wouldn't eliminate a variable. I need to subtract one from the other, because that will actually get rid of a variable for me and give me a whole new equation that I can work with. So that's what I'm doing. And when you subtract one from another, you subtract every single piece of that equation from the other. So this negative, this minus sign distributes to every single element in that equation. So instead of x plus 3y plus 2z equals 5, now I have negative x minus 3y minus 2z equals negative 5. So now when I combine these equations, right, minus x, that's 0. I've eliminated a variable. And then I'm going to combine the rest of these. 2y minus 3y, well, that's a negative 1y. 3z minus 2z, well, that's a positive 1z. 9 minus 5 gives me 4. So now I've got another equation. I've labeled it equation number 4 that I can work with. So I also need two equations, right, that have 2 variables. Since I've done this first one, where I eliminated x and I was left with y and z, I need to do the same thing for 2 other sets. I picked 1 and 3, right? But I could have picked 2 and 3 if I wanted to. Those are the other combination. That's another combination that would have worked. But I picked 1 and 3. You could have picked 2 and 3. It'll still work. The whole point is to eliminate that same variable so that we can get the same 2 variables in our equation that we have at the end here. So I'm subtracting equation 3 from equation 1. I distribute, remember, I distribute this minus sign to every single piece. So x minus x is 0. 2y minus 4y gives me negative 2y. 3z plus z, 4z, 9 plus 5, 14. So now I've got 2 equations, number 4 and number 5 here, that I can put into a system of equations with two equations. That'll allow me to solve for y and z. So I can still use elimination by multiplying one equation by a number that creates matching coefficients. I still want to use elimination. See, look at these. Look at these. I've got -1 on my y coefficient here and a -2 on my y coefficient there. Those don't match. I've got a 1 on my coefficient for z here and a 4 on my coefficient for z here. That doesn't match either. We can force our coefficients to match by multiplying one equation by a number that will get matching coefficients. So here I've multiplied my top equation by 2. I picked 2 because when I distribute this 2 to each of my pieces in my equation, my first element here, I've got -2y. Well, now I have matching coefficients, right? But except this 2 needs to go to every piece. So -2y plus 2z equals 8. So that's my new equation. And now I can eliminate, right? These are both minus signs, which means I need to subtract one from the other. And again, this minus sign gets distributed to each piece. So that gives me these guys here. Whoops. That gives me these guys right here. So now when I combine them together, -2y plus 2y, that's 0. 2z minus 4z gives me -2z. 8 minus 14 gives me -6. Now I finally have one variable, and I can solve for z. So when I do solve for z, I get z equals 3. And then I'm going to take this, plug it back into one of these equations. So I picked the top one. I picked the top one from up here. You can pick the bottom one, it'll still work. So -y plus 3, because that's my z, equals 4. Now I can solve for my y. Now I have y equals -1. And then I go all the way back to my top equation up here, plug in my z and my y, do some basic algebra, solve for x, and it gives me my final solution of x, y, and z. This is kind of a lot. This is kind of a lot. If you don't want to do elimination, if you don't really remember that from doing system of equations, substitution will always work. You can always come back and do substitution. Give the homework a try. There's not a lot of questions because these problems are so involved. So give them a shot. Try to follow these steps. Use substitution. Use elimination. I think some of them will kind of walk you through the steps. If you have any questions, please let me know. Bye, guys.